All right, so here we're supposed to find fk for the given polynomial using the remainder theorem. So remember, what that means is we're going to do a synthetic division with this k with all of these into the thing. So we're going to have a -6 out front, and then we're going to have a 5, a -4, a 3, 5, 4. Oh, we don't have a 3, so we better add that 3 in there for the power, because it's going to be a 0x cubed. And if we forget that, that's going to cause us some issues here. So 5, 4, then plus, all right, not plus, just a 0. Well, I want the eraser. 5, 4, -4, and then 0, and then 2, okay, so that's a 3. Then, why do I have two twos? You know what I'm betting? I'm betting this is supposed to be a 3. And then that would work better. All right, so erase again. I think that was the issue. I think it was a typo here. All right, so 5, -4, and then 3, and then -2, and then a 1, and then a -1. All right, so lots of numbers here. So bring down our 5. So that's a 5. That's going to be a -30. So that's a -34. And it looks like I'm going to have my calculator out to do this. And so 6 times 34, so it's a negative, oh, it's positive because it's negative times negative, 384. So then that's going to be a 6 times 34, not 64. All right, 204. All right. I'm not doing this problem right at all. I need to probably just start over, but that's okay. So that's a 34. I took that times 64 instead. So 6 times 34 is 204. All right, so now let's get back on track. Now it's a 207. Now 207 times a -6 gives me a -1242. Plus a -2 is a -1244. And so 1244 negative times a -6 gives me a 7464. Add that to 1 is 7465. And if we take that times a -6, we get a -44,790. And add 1, it's -44,791. All right, so f of -6 equals -44,791. Now, I think it almost would be easier just to plug that in. We could have just said, well, what is that? So it's plug it into our calculator and get it. But this is showing that we can do synthetic division to actually find out what a function value is at a specific point in time. Okay. As long as you have, your 3 here correctly, and then you multiply 6 times 34, not 6 times 64. All right, so I think that should be good. And so let's go to the next one. So now we're supposed to use the factor theorem to find all real zeros given a factor and f of x. All right, so what does that mean? Well, this is going to be our factor. So k is 3. And so we're going to take 3 and divide it into, well, we have 3, 2. Now we have 0 of those. And then that. So we have a -5, 16, 0, -9. So this time I do have it correct because there was none. So we have that. And so now we just start doing synthetic division. So that's a -5. That's going to be -15. That's a 1. That's a 3. That's a 3. That's a 9. That's a 0. Aha, so we were good. So that is a factor. So now what does this give us? Well, that's an x squared, that's an x, and that's a number. So we're going to have a -5x squared plus x plus 3. Now, can we factor that one? I don't think so. I don't see a way. So that means we better use the theorem here. So that's going to be x equals minus b plus or minus the square root of 4a, or b squared, sorry. Forgot my b. B squared minus 4ac all over 2a. Okay. So a minus 1 plus or minus square root of 1 squared is 1 minus 4 times a, which is a minus 5 times c, which is a 3, all over 2 times a minus 5. And so we get a negative 1 plus or minus the square root of, okay, that's going to be 20 times 3 is 60. That's positive plus 1 is 61, all over negative 10. I don't really need that long of a root there, I guess. So we'll make it a little shorter. And so we have those two values here. So what do we get? We get x equals 3, get x equals a minus 1 plus the square root of 61 over negative 10. But what is that equal to? I just thought about that. Well, that's going to be equal to a 1, and then it's going to be a minus the square root of 61 all over 10. And then if we did the other one, it's going to be x equals negative 1 minus the square root of 61 all over negative 10 again. Won't let me do it. It's too low here. So let's put it a little higher. And so the other one was going to be x equals negative 1 minus square root of 61 over negative 10. And so that's going to be 1 plus square root of 61 over 10. So we have this root, real 0. They have this real 0. And we have that 0. Okay. So those are 3 zeros. And we expect 3 of them based on our cubic power here. All right, so now we're supposed to use Cauchy's bound to find the interval containing all real zeros. So, we've been using it to, once we find one where it has, all the pluses are on and minuses, we have an upper bound. But now we can find what our upper and our lower bound are. And what we're going to do is we're going to take each of these values divided by that. So we're going to take that divided by that. We're going to take that divided by that. We're going to take that divided by that. Okay, so we'll take 20. And we're taking the absolute value. So 20 over absolute value of a negative 2, that's going to be equal to 20 over 2. And then we're going to have absolute value of negative 49 over the absolute value of negative 2. So that's going to be 49 over 2. And we're going to take the absolute value of 19 over the absolute value of negative 2. So that's a 19 over 2. Well, this is 10. This is 48. It's going to be 24.5. And that's going to be a 9.5. And so which one's the largest? Da, da, da. So remember, this is a interval from m plus 1 to m like that. And so we're going to have a negative, if m is 24.5, so it's going to be a negative 25.5 to 25.5. So from the negative of it to the positive of it. And so that, based on Cauchy's bound, is going to be our limit. So it's going to go from negative 25.5 to positive 25.5. Okay. All right, so let's pause there and we'll come back for some more.